and welcome to No Physics with me. Hope all are doing good. Yes. So we have already started with physics, CBSE class 10, topic light reflection and refraction. So this is part 2 video. Part 1 video we have covered basics of light. Okay, so what is light? Then what are all the basic phenomena related to light? Reflection, we saw what is reflection, then types of mirrors, and then we saw laws of reflection. Yes, so in this session we will see important terms related to spherical mirror. So already we discussed what is a spherical mirror and types of spherical mirror. So we will see a detailed understanding, or we will go with a detailed understanding of spherical mirrors. Okay, some of the important terms that we have to know related to spherical mirrors in order to draw the ray diagram. Then we will go with the rules to draw the ray diagram, and then we will see how image is formed using the ray diagram. Clear? Yes. So this chapter completely we are going to see light propagating in a straight line. So with that only we are going to see different phenomena. Okay, so this property of light to travel in a straight line is nothing but called as rectilinear propagation of light. Okay, light traveling in straight line, that property is called rectilinear propagation of light. Okay, and also we have to know one important thing, the speed of light in vacuum. Speed of light in vacuum, this already we have learned from previous classes. Still, this is very important value. So the speed of light in vacuum is 3 into 10 power 8 meter per second. So as already we have discussed, it does not require any medium to travel. Light does not require any medium to travel. It can travel even in vacuum. So the speed of light in vacuum is 3 into 10 power 8 meter per second. Clear? Yes. So now let us see what are all the important terms related to spherical mirror. So definitely one should know this. Only then you know how to draw a ray diagram, as well as you will understand how image is formed in spherical mirrors. Okay, so already we have seen in previous session what is a spherical mirror. A spherical mirror is one in which one of the reflecting surface is a part of the sphere. Yes, there are two types of spherical mirror we saw. One is concave and another is convex. So those who have missed part 1, watch it and come. There clear explanation of everything is given. Okay. Yes. So now we will learn each term one by one along with the diagram. So we'll have a better understanding. We will have concave as well as convex mirror. We'll learn for both together. Okay. So the first term is, first let us draw both the mirrors. So let me draw here. Okay. Concave mirror and convex mirror. Okay. How is concave mirror drawn? A reflecting surface is bulged inwards. Okay. This is nothing but concave mirror, and this is the polished surface. In convex mirror, your reflecting surface is bulged outwards, and this is the polished surface. Okay. So the first term we are going to learn is pole. What is pole? Pole is nothing but the center of this reflecting surface is called pole. In both mirrors, the center, this is the reflecting surface, right? This is a part of a sphere. So let me draw it completely. Kindly adjust my diagrams. Okay, so this is a sphere and one part of it is cut and it is polished on one surface, so the other surface is reflecting. So this central point of that reflecting surface is called the pole in both the mirrors. Okay, now the second point is center of pole is represented by the letter P. Okay, you're clear with pole, right? Yes. Next we will learn center of curvature. So what is center of curvature? Center of curvature is nothing but this point, which is the central point on the sphere. Okay, see, this is the sphere and the center point of the sphere is nothing but called the center of curvature. You understand? Yes. Now there is something called principal axis. So principal axis is nothing but an imaginary line joining center of curvature and the pole is nothing but called the principal axis. An imaginary line joining center of curvature and the pole is called the principal axis. Clear? Yes. Next, we will learn a radius of curvature. Is represented by the letter R. So you already know what is radius, right? Half of diameter. Diameter means a line joining two ends of a circle and half of it is nothing but radius. So if I draw a line from here to here, can I say it as radius? Yes. Similarly from the center to this is the radius, right? So this is nothing but called the radius of curvature. So I'll write it as R, okay? Radius of curvature. A line joining the central point and any point on the sphere is nothing but the radius. Yes. So this is the radius of curvature. Next we have something called focus and focal length. For that, before learning this we have to know two things. One is concave mirror is called as converging mirror. This is concave mirror, right? This is called as converging mirror and convex mirror is called as diverging mirror. You know the meaning of these two words. Converging is nothing but where after reflection all the rays meet is called as the converging. Converging point means where every rays come and meet. Okay. Diverge means it moves away. Converge means it comes together. You understand? So, in concave mirror is called as converging mirror because all the rays after reflection they meet. Okay. Whereas in convex mirror after reflection they go to different directions. This is what the meaning of converging and diverging. So, focus is the point. In concave mirror, focus is the point where all the parallel rays after reflection meet. You understand? So focus, the term itself will say focus means you get a clear picture, right? Yes, that's what it means. So there all the rays meet, converges together and meet at a point after reflection, and that is nothing but called the focus. Whereas in convex mirror, it is a point where all the rays appear to meet. Okay, we will learn it through ray diagram, so we'll have a clear understanding what I mean by appearing to meet. Okay, yes. Then focal length, you know, focus usually comes in between the center of curvature and the pole. Okay, your focus will always lie between the center of curvature and pole. So here is your focus. You understand? Your focus always lie between the center of curvature and the pole. Okay. There is also something called as focal length. Focal length is nothing but the distance between the focus and the pole. You understand? The distance between this distance is nothing but called the focal length. Here, sorry. This distance is called the focal length. Okay, and there is also relation between focal length and radius of curvature. So focal length is nothing but R by 2. That is, if you know radius, then twice of the radius is nothing but radius means radius of curvature I am meaning. So if you know the radius of curvature, so twice of radius of curvature, twice of focal length is the radius of curvature. Or if you know the focal length, then you can calculate the radius of curvature by multiplying it by 2. Okay. So suppose I'll tell you, if you know the focal length, then radius of curvature can be calculated by f into 2. 2f. Okay. R is equal to 2f. F is equal to R by 2. You understand? Yes. So these are all the important terms that you have to know in spherical mirror. Once again we will see. So the first, let us draw two mirrors. So concave mirror and convex mirror we have drawn, along with the sphere we have seen. Okay. So this is the reflecting surface and here this is the reflecting surface, and the center point of the reflecting surface which is a part of the sphere is nothing but called the pole. The center part of the reflecting surface, which is a part of a sphere, is called the pole. Okay. The second we saw the center of curvature. Center of curvature is nothing but the center point of the sphere from which the reflecting surface is taken. Okay. The center part of the sphere is nothing but called the center of curvature. Then principal axis is nothing but the imaginary line joining center of curvature and the pole in both the cases. And radius of curvature is nothing but a point from the center of the sphere to the sphere. Okay. That is from here to here is nothing but the radius of curvature. Then we saw concave mirror is a converging mirror, whereas convex mirror is a diverging mirror. Then we saw what is focus. Focus is nothing but where all the rays meet. In case of concave mirror, all the rays meet after reflection. That point is known as focus. It meets on principal axis. Okay, that you have to note. See, in this line only it is meeting, right? So where all the rays meet after reflection on the principal axis is called the focus, and where it appears to meet in the case of convex mirror. Okay, and the last thing is focal length. You know, focal length is the distance between the focus and the pole. Okay, and there is a relation between the focal length and radius of curvature. So f is equal to r by 2 or r is equal to 2f. Depending on what value you want, you can change this formula. Clear? Yes. There is something called aperture. Okay, which is nothing but the diameter of this reflecting surface is nothing but called the aperture. Okay, I will draw it for your clear understanding. This is the reflecting surface, right? This diameter is nothing but called the aperture. Okay, or you can say how much light. Okay, this aperture decides how much light is entering for reflection. You understand? See, if the size of this aperture is small, only less amount of light will pass through this. Correct? If the aperture is big, more amount. Okay, so it tells this area tells how much amount of light is coming and falls on the mirror in order to reflect. You understand? Yes. So this is nothing but called the diameter of the reflecting surface. So the term is aperture. A-P-E-R-T-U-R-E. Understand? Yes. So the next topic is representation of images formed by spherical mirror using ray diagram. So the topic is very big. Actually, this is nothing but you are going to follow 4 rules in order to draw the ray diagram. Why we are drawing ray diagram? So plane mirror characteristics we saw, right? Image formation characteristics. How we saw? So the image formed is virtual erect, it is behind the mirror, object distance and image distance are same, object height and image height are same, right? Yes. Similarly, in spherical mirror also we are going to say this by keeping object at different places. Say this pen, okay, this is my object, okay. So now where the image is formed, what type of image is formed? Say the nature, size and position. We are going to find this. So in order to find this, we use a ray diagram in order to find where the image is formed, whether it is enlarged or diminished or real or inverted, whatever it is, okay. So we are going to place this object at different positions and we are going to find where the image is formed. Clear till this? So that is nothing but the topic is. So we are going to follow 4 rules. Out of that, any 2 rules you can use in order to draw a ray diagram to locate the image, okay. So you have 4 rules. In that 4 rules, 2 rules you can use in order to draw a ray diagram, okay. You can ask me why we will use 2 rays, okay. Why we are using 2 rays? We have n number of rays falling on this object and n number of rays are reflected. But while drawing, if we use n number of rays, it is tedious as well as it won't look good, right? That is why we use basically 2 rays. At least 2 rays is required in order to locate an image. Clear? Yes. Now we are going to see what are all the 4 rules and then we will see how image is formed. Clear? Yes. So first we will talk about concave mirror and then we will go with convex mirror. Okay? Yes. So concave mirror is what mirror? Converging mirror. Then and there you must remember this. Concave mirror is a converging mirror. we have lens also in this chapter. So there you will have an opposite process. So don't confuse that. That's why I'm saying any one, if you remember properly, the other thing you can do the opposite way. Okay. So concave mirror is a converging mirror. So let us start with the first rule. So the first rule is like this. Ray parallel to principal axis. Okay, I'll write in short everything. A ray parallel to principal axis after reflection passes through focus. A ray parallel to principal axis after reflection passes through focus. Okay, so this is what we are going to draw. So the first thing, you have to draw a concave mirror. Right, for concave mirror only we are drawing this, right? Yes. Now locate the positions. So here you have pole, and here you have center of curvature, and a line joining center of curvature, and pole is nothing but the principal axis, and you have focus in between center of curvature and pole. Correct? Yes. Now you are going to draw a ray. Always remember, whenever you are drawing a ray, arrow mark is very important in order to indicate which direction it is moving. Clear? So a ray without an arrow mark cannot be considered as a ray. Okay? So always remember this. Now read this. A ray parallel to principal axis. So now this is the principal axis. So I am going to draw a ray parallel to principal axis. Correct? This is how we draw it. Yes? A ray parallel to principal axis after reflection. After reflection. When reflection occurs? When it touches the mirror, right? Yes. So you have to touch this to the mirror. Only then you have to draw the reflected ray. You are clear? Without touching this mirror, if you draw a reflected ray, the diagram is wrong. Clear? Yes. So, a ray parallel to principal axis after reflection passes through focus. So, where is our focus? Here. Yes. So, passes through focus. So, after passing through focus, in which direction it is moving? In this direction, right? So, that also you have to indicate by an arrow. So, this is the first rule to draw a ray diagram. So a ray parallel to principal axis after reflection passes through focus. Yes. Now we'll go with rule 2. Okay. A ray passing through focus after reflection is parallel to the principal axis. So if you just see the previous rule and this rule, it is just the vice versa of the previous rule. So in previous rule what we learned? We have a mirror. Okay, first we'll draw. Okay, mirror, pole, then center of curvature, and in between them we have focus. Okay, and principal axis. Right? So in previous rule what we saw, a ray parallel to principal axis after reflection passes through focus. Now a ray passing through focus. Okay, a ray passing through focus. My incident ray is now passing through focus. After reflection is parallel to the principal axis. So this is how you have to draw the second ray diagram. See, a ray parallel to a ray passing through focus after reflection is parallel to the principal axis. So first and second rule are vice versa. Any one rule if you study, the other rule you can easily write. Okay. So this is how you have to draw the second ray diagram. The third rule is a ray passing through center of curvature. So I will represent it by C. Okay. A ray passing through center of curvature after reflection is reflected among the same path. Okay. So let us draw the ray diagram. So this is the concave mirror. We will locate the pole, center of curvature and focus. Okay, this is the principal axis. So every time try to draw along with me, so you'll easily understand. Okay, so now read. A ray passing through center of curvature. Where is my center of curvature? This one, right? So now I am going to draw a ray passing through center of curvature after reflection. After reflection means when it touches the mirror, it is reflected along the same path. Okay, so this is the third rule. I'll tell you the reason later why it is reflected along the same path. Okay, and for now you understand the rule. So a ray passing through the center of curvature after reflection is reflected along the same path. So you have to represent it by the arrow marks. So this is the incident ray. After reflection, the same path it follows and the direction alone you have to change. Clear? Yes. Now we will go with the fourth rule, the last rule. Okay, so this rule is very easy. We have already learnt it. Okay, a ray passing obliquely. Ray passing obliquely. Obliquely means, I'll show you, in this way, sideways. Okay, a ray passing, slanting way. Okay, a ray passing obliquely on the pole of the reflecting surface. On the pole of the reflecting surface is reflected obliquely. Okay. Now I'll draw the ray diagram. From that you can understand what we have learned it previously. Okay. So this is my mirror. This is the pole, center of curvature and focus. So what does the definition says? A ray passing obliquely on the pole of the reflecting surface is reflected obliquely. Okay. Now it follows the laws of reflection. You know the laws of reflection, right? First law, what does it say? The angle of incidence is equal to the angle of reflection. So how much angle it is making here? The same angle it makes here. Okay. This is what the fourth law is. So I think you are all clear with all the four laws. Yes. Now we will try to do it for convex mirror. Try to do it by yourself. The same rules apply for convex mirror also. Okay. Yes. Now we will draw for convex mirror. So convex mirror is a converging or diverging mirror? Diverging mirror. Okay. So I am not going to write the rules. Instead we will draw the diagrams alone. Okay. So what is the first rule? A ray. Okay, first let us draw convex mirror, then locate the positions. Okay, here is the pole. Always remember your center of curvature for the convex mirror is on right hand side because your sphere is like this. Yes, so this is the center of sphere and here is your focus. Now I am going to draw a line. Okay, so done till this, right? So the first rule says a ray parallel to the principal axis. So this is the principal axis. So this is the parallel ray. A ray parallel to the principal axis after reflection passes through focus in case of concave mirror. Here what actually happens is it is diverging mirror, right? So what will happen is it goes like this. Okay, it will not meet at any point. Instead it goes in some other direction. All the rays will go in different direction. Okay, it is a diverging mirror. So how we can say is, when we extend these two rays, you can see that it appears to come from focus, right? When you extend these rays using dotted line, you can see it appears to come from the focus. So that is how you have to draw the diagram in case of convex mirror. So here the image formed is not real. It is behind the mirror. So we cannot form the real image, right? So this is how you have to draw the ray diagram for it. Okay. So a ray parallel to the principal axis after reflection appears to pass through the focus in case of convex mirror. Okay. Now we will go with the second rule. Okay. For the second rule, first let us draw the convex mirror. Okay. Convex mirror, then pole, center of curvature and focus. Okay, now what is the second rule? A ray passing through focus. Okay, so here actually it does not pass through focus, but we'll draw a imaginary line. Okay, like this. A ray passing through focus. Okay, first draw the line and draw an arrow. A ray passing through focus appear after reflection appear parallel to the principal axis. You understand? This is how you have to draw the ray diagram. Because here actually there is nothing called focus. Nothing comes from focus. Okay, but we will imagine it to come from focus. Okay, so a ray passing through focus after reflection appears parallel to the principal axis. Clear? Yes. So the third and fourth one we'll draw. Okay, so third convex mirror is like this. Yes. Okay, and this is the whole center of curvature and focus. Okay, what is the third rule? Third rule says that a ray passing through the center of curvature is reflected along the same path, right? Okay, so this is my center of curvature. So how will I draw the ray means like this you have to draw. Okay, so always remember right hand side when you draw, in case of convex mirror, right hand side when you draw you should use dotted lines, which means it is imaginary. Okay, it is not real, it is imaginary. Whereas left hand side you should draw as a straight line only. Okay, now the direction also you have to mention when it is a straight line. Okay, not dotted lines. Okay, so a ray passing through the center of curvature appears to get reflected along the same path. So you can use the arrow the same way. You understand? Yes. And the fourth rule is what is the fourth rule? A ray obliquely incident on the pole of the principal axis is reflected along the obliquely. Okay, so like this. Okay, so fourth rule you will have the same diagram for both. Okay, and other rules here the same thing only but appears to come, so you will use the dotted line since it is diverging. Okay, this is diverging mirror and that is converging mirror, so that real thing is happening here, we will find it imaginary. Okay, yes. So in this session we have seen what are all the important terms related to spherical mirrors, and then we have seen what are all the rules to draw a ray diagram. Okay, so out of these 4 rules only 2 rules we will use. Any 2 rules we will use to draw the ray diagram, and next session we will see image formation using ray diagrams. Today we will not take it because if we take it you will find it difficult. Once you are thorough with this concept we will go to the next one. Okay, so try practicing this. That is, try practicing how to draw ray diagram for both concave and convex mirror. Once you are thorough, then go for the next topic. Okay, yes. So if you find it useful, do share it with your friends. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.